So today we're unpacking a really fascinating and frankly vital piece of the booming advanced chemical manufacturing industry. We hear so much about the massive scale of the renewable energy sector, right? The electric grids, the massive energy storage, the fuel cells. But in this explainer, we're zooming in on the human element behind all that tech. We're looking directly at the International Sustainability Standards Board's SSB standards for fuel cells and industrial batteries. And we are specifically focusing on workforce health and safety. I'm genuinely excited to guide you through this because it completely changes how we view clean energy production.
I want you to just keep this specific phrase in your head right now: protecting the hands that build the green transition. You see, it is incredibly easy to get caught up in the macro view of a clean energy economy. The shiny solar panels, the massive battery storage facilities, the promise of a zero-carbon future. But then there's this microscopic, gritty reality down on the manufacturing floor. The advanced batteries and fuel cells powering this transition, they're built through highly complex, really chemical-heavy processes. Understanding how companies protect the people on those exact production lines is absolutely essential if we want to understand the true sustainability of these technologies. Okay, let's dive into this with Section 1, the green transition's hidden cost. Manufacturing industrial batteries and fuel cells isn't just about snapping together clean plastic parts. We're talking deep chemical processing, extreme temperatures, and incredibly volatile materials. The standards highlight a pretty blunt reality here. Workers face serious hazards that carry severe health impacts. But, and this is key, SASB doesn't just view this as a simple human resources issue. It is a critical financial risk. Failing to manage safety processes doesn't just harm workers, it directly exposes companies to severe regulatory fines and massive litigation. Basically, if a company isn't managing safety, they literally aren't managing their bottom line. Moving right along to Section 2, acute versus chronic hazards. To truly assess a company's risk profile, we have to understand exactly what dangers plant workers face every single day. And this brilliantly illustrates that by breaking it down into two distinct categories. First up, we've got the acute risks. These are the sudden, violent accidents you might immediately picture when you think of an industrial plant. Fires, explosions, freeze burns, electrocution. They are immediate and highly visible. But then there's the chronic risk. This is the slow, silent threat of exposure over months or even years to heavy metals and chemicals like lead, cadmium, arsenic, sulfuric acid, and a whole host of industrial solvents. This standard gets even more specific and, frankly, quite alarming when discussing these long-term hazards. Companies are absolutely required to report on their efforts to reduce exposure to known or suspected carcinogens, teratogens, and mutagens. For those who might not be familiar with those terms, we're talking about substances capable of causing cancer, causing embryo malformations, or actually inducing genetic mutations. The sheer severity of these human health hazards is exactly why sustainability reporting in this specific sector is so incredibly rigorous.
Which brings us to Section 3, the defense line.
So with risks this massive, how does the industry actually protect its workforce? Well, if we were to walk a virtual manufacturing floor right now, we would see a hierarchy of controls in place. The defense starts with comprehensive risk assessments and rigorous safety training. From an engineering standpoint, a major protective step is automating processes to physically remove the human from the hazard altogether. But where workers do need to be present, standards look for robust investments in improved plant ventilation and the strictly enforced use of personal protective equipment, or PPE.
Now, beyond just the physical equipment, there's the biological monitoring side of things. The standards place a very special emphasis on monitoring workforce blood lead levels, or BLL. Companies have to discuss exactly how they enforce maximum threshold limits and strict testing frequencies. They also need to prove how these policies align with heavy-hitting regulatory organizations, like OSHA and the American Conference of Governmental Industrial Hygienists. But here is the absolutely crucial point. This safety umbrella has to cover everyone. The SASB standards explicitly state that these protections and monitoring efforts must apply to the entire workforce. That includes direct employees on the payroll, sure, but also contract employees, temp workers, and labor brokers, because a hazard doesn't distinguish between a full-time employee and a contractor, and neither should the safety protocols.
Let's move to Section 4 and see how this builds. Measuring worker safety. Look, it's one thing for a company to say they have a great safety culture. It is another thing entirely to actually prove it to investors. The universal metric used to prove it is the TIIR, or Total Recordable Incident Rate. Now, to be clear, this isn't just a count of every scraped knee on the floor. SASB strictly defines a recordable incident as an injury or illness that results in death, days away from work, restricted work, loss of consciousness, or any medical treatment that goes beyond basic first aid. It really cuts through the noise to measure the most severe safety failures. And here is exactly how they calculate that to ensure fair comparisons across the entire industry, regardless of whether a company has 100 employees or 10,000. They take the total count of those recordable incidents, multiply it by 200,000, and then divide that by the total number of hours worked by all employees in that year. And they use this exact same formula to calculate the fatality rate as well. Now, what's really interesting about this slide is that specific number, 200,000. It might seem completely arbitrary at first glance, right? But it's actually a beautifully simple standardization tool. It represents the total number of hours that 100 full-time workers would provide annually if they worked 40 hours a week for 50 weeks a year. So when a company reports a TIIR of 2.5, it translates directly to meaning they had 2.5 severe incidents for every 100 full-time workers. It just perfectly normalizes the data so investors can actually make sense of it. Section 5. The bottom line. Taking a step back for a second, why does tracking these incredibly granular safety data matter so much to a company's bottom line? Well, as the standards point out, it's a direct chain reaction. Companies with strong safety internal controls obviously see improved workforce health performance. But structurally, this mitigates those super expensive regulatory fines and drastically lowers litigation risks. Simply put, a safe plant is a reliable plant. Constant accidents, high turnover due to toxic exposure, or sudden plant shutdowns, those destroy profit margins in an industry that already operates on incredibly tight economics. Which brings us to our final and maybe most important thought. The battery and fuel cell industry is absolutely foundational to reducing global emissions and building a sustainable future. We all know that. But as you've seen today, the process of making that technology is fraught with intense chemical and physical dangers. It forces us to ask a really tough question. Can true sustainability exist without workforce safety? Is a technology really clean if it fails to protect the very hands that build it? I'll leave you to ponder that one. Thank you so much for joining me for this explainer today, and as always, keep asking the big questions.